Hello and welcome to the Extended Greg YouTube channel. I'm Greg and today we're going to be talking about Raspberry Pi GPIO using Alpine Linux. Pretty much it's going to be an exciting foray into what features you can add into your projects. We're going to be covering both Python as well as a lower level method to be able to actually integrate it into shell scripts. So let's get right into it. So what I have right here is we have a Raspberry Pi 3B+. I'll move this away a little bit, but pretty much I have an LED already connected to it, as well as a button. So that way we can test input and output. The LED is just directly connected between one of the pins and ground, and the button is connected to 3 pins. So it's connected to the 3.3 volt line. It's connected through a resistor, I should say, to the 3.3 volt line. It has a connection to the pin that is literally in parallel with that. So if we follow the purple wire, it actually goes to a GPIO pin on the board itself. Actually, that's as far as I can actually get it over. So, but you can see right here, it's just a resistor. It's a 4.7 kilo ohm resistor in this particular case. I'd probably generally go with 10, but that's what I had around. But what it's doing is it's acting to pull up the pin. So when the button is not depressed, this is a normally open button. So when it's not pressed, it's going to bring the pin high, and when it is pressed, it's going to ground out that pin and it's going to make it low. So we're going to show you how to actually go through and read that, but we also have the ability to disconnect it in case we want it straight through. All right, so let's go over to our Raspberry Pi. I've already pre-configured it with the necessary packages that we're going to need. But specifically for Raspberry Pi 3, we're going to need a package which is Pi 3 RPi.GPIO. So we'll just go through the motions here. You'll see I have it installed, but you do apk add and then py3-RPi.GPIO. Right, in our case, it's already installed. Now, as part of that, it's going to install the Python 3 actual runtime. And that will give us an environment to be able to run Python scripts, things like that, as a part of that. So we could have installed that separately. We could install this after the fact, but if you install it, it will definitely install Python 3. So it's an easy way to get started if you just want to play around with it. But we're going to actually do this in real time through the interpreter. So we're going to type Python, and that will take us into a new prompt. We see the 3 carets pointing to the right, and pretty much those are the equivalent of our shell prompt, but to let us know that we're running in the Python environment. Now I'm quickly going to pull up the reference and notes that I have here, but we're going to cover 2 examples. One of them is just going to be the output, so I'm going to keep right up here in the top of the screen. I'll keep this up so you can see when I'm pushing the button, and you can see when the LED is lit. And believe me, you'll definitely see it. So first, let's actually just go through a basic example. Okay, so we want to actually take a look. We want to light up an LED in a repeating fashion and just blank it, the standard blank LED. So first thing that we need, because we're defining this just like we would a Python script, is we need to import our GPIO library that we just installed. And so we're going to use the import command. So it's going to be import capital RP lowercase I dot cap all caps GPIO as GPIO. And what that is RPi is the library.gpio is what we're calling out of that library. And then as GPIO just means that we want a shorthand name for it. We're going to give it another name, but that calling a GPIO is just going to be a lot easier than repeating the same thing over the RPi part of it over and over again. So we run that, no errors. Let's keep going on from there. So next we're actually going to want a delay command or something to cause the application to sleep for a second. To do that, we're just going to use time. So we're going to import the time function, and that will give us access to be able to call that command. Now, we want to go ahead and initialize our pin, so that way we can actually know which one that we're going to blank. So we want to do GPIO, which is that shorthand that we made before, .setup. So we're going to tell it, or set mode. So we're going to tell it what numbering system that we're going to use in order to address our pins. There are two options for this, which is we can either do BCM, which is the standard GPIO numbers, or board, which is the pin number as it appears on the board, so 1 through 40. So in our case, we're just going to use the GPIO number. It's just going to be easier for us, but you use what's best for you. So we're going to do GPIO.BCM. All right, so now we've gotten everything set up. Let's actually get into defining what we want it to do. So we want to set a variable where we tell it what pin we're actually going to use. So we're going to create a variable called LED pin, and we're going to set that equal to what we're actually, to the pin that our LED is connected, which is GPIO.17. So we're just going to set it to 17. And then we're actually going to set up that pin in order to make it an output. Because obviously any of the pins, GPIO pins, can be inputs or outputs. So we want to make sure that we're actually setting it up as an output. So we'll do GPIO.setup, and then we'll do LED_pin to reference our variable, comma GPIO.OUT. Notice how pretty much everything is caps. I mean, granted, we made the variable caps, but a lot of the other commands are as well. So we hit enter. Excellent. It should be set to go. So before we actually code anything automatically, let's actually just try it. So we'll send an actual 1 out to that pin. We'll set the pin to 1, which will make it high, and that will actually have a voltage to drive the LED. To do that, we're going to do GPIO.output, and we're going to do LED pin, and then we're going to do GPIO.high. Now we see that the LED turns on, right? Just as soon as we execute the command, it's doing what we want it to do. So this doesn't have to be an LED. It could be a relay. It could be any number of things that you could drive with a voltage output to be able to, change things in the physical world that, you want to be able to control through software. So it's very useful for that. And in order to turn it off, we would run the same command, but with setting it to low. And that turns it off. So what we could do now is we could actually run this in a loop. So we could do, and I'm actually going to make it so it exits on its own, but we're going to do counter equals 0. And then I'm going to remember this off the top of my head because so my notes actually just said while true, which means it would loop forever, but that's kind of annoying. So we're not going to do that. So let's do, counter equals 0, and then we're going to do, actually we don't have to do counter equals 0. We could just do a for loop. And let's do (0.10). Yeah, for I in 0.10 colon. Nope, not a thing. Do I have to put in brackets? I'm trying to make a range so it counts. I don't remember it. Let's just do while true. True, of course, has a capital T on it. Right, so the ... means that we're inside of a loop or inside of another function, things like that. So we're going to do GPIO.output. I have to spell it right, otherwise it will error. And we'll do LED pin GPIO.high. All right, and then we'll do another command. And notice I'm hitting the tab key because Python itself recognizes whether you're inside or outside of a function based on whether you hit tab. So your white space determines whether you're still in the function or whether you've exited out of it and are doing things generally. So we're going to do a delay. So we're going to do time.sleep, and we're going to set it to 1 second. Then we'll go in again. We're going to do GPIO.output. LED pin GPIO.low. Right, so we went high, waited a second, we went low, and now we're going to wait another second, and that'll end the loop. All right, so now I'm not going to tab, I'm just going to hit enter again. And we see that the light is blinking on and off every second. Perfect. In order to exit the while loop, we're just going to hit Control-C. That will keep us in our environment, but just bring us back to the prompt. But it's going to stay at whatever state it was last, which is fine. So next, let's actually look at taking an input. Okay, and in this particular case, it's going to be a little bit longer, but I think it's pretty much based on the same kind of principle. But we're going to add something new to it. We're going to add something called button pin. So we're going to set a variable called button pin, and we're going to set that to 14. Then we're going to set up our input pin, and we have two options here. So we can set it up with an internal pull-up or an external pull-up. And I'll show you what that means. So there's two options that we could do with it. So there's pull-up resistors, there's pull-down resistors, and then there's internal and external variants of those. What we set here by doing pull up down as part of the setup command will actually activate an internal pull up resistor. So we can decide whether we want it to be pulled up, pulled down in order to detect a rising edge, as it goes up. For example, if we were pressing it, or if we were detecting a falling edge, like when we were releasing it. So in this particular case, we're going to set it to GPIO.PUD_, so PUD stands for pull up, down, up. All right, before I do that, let's go over to the overhead really quick. I need to disconnect this right here, okay? Because we don't want to add an external pull-up at the same time that we're giving it an internal pull-up. It could cause it to have problems. And actually, it could break your board. So be very cognizant of how you connect it. So back over here. So we're pulling it up automatically. We have our two pins connected. So it's just going to currently ground and to our... So it's connecting from ground and our GPIO pin to the button, which will then short it out and bring it to ground. So the pull-up button, the pull-up resistor internally, when we press it, it's gonna go from a 3.3 volt down to 0. So now let's actually take a look at it. Let's see if we can just do a quick loop and find out whether it's on or off. So let's just do GPIO.input and then just our pin name. Right? And right now it's set to 1. If I press it, now it's 0. If I let go, now it's 1 again. So what can we do with that? Well, maybe we can interact with our LED and make it do something there. So let's make another while loop. So we'll do while true, and then we'll say button state. So button state equals GPIO.input button pin. Then let's actually do something with that by putting an if statement. So we'll put if button state equals false, again, caps for the F. So now we're 2 levels deep. So 2 tabs. We're going to do GPIO.output. I did spell that right, but I did caps. Output. LED pin, just like before. GPIO.high. Then we'll do time.sleep, and we'll do 0.2, right? So it'll do 1/5 of a second. Then we'll do GPIO.output LED pin, GPIO.low. I'm making sure I'm spelling this right, otherwise it's going to error out and I have to type it all again. So just something to keep in mind, because I'm not doing this as a script. If there was a script, I could go back and edit it, but right, so that's our if statement. But obviously, if we push the button, which would make it true, or actually, I'm sorry, if it would make, so when it's false, that means that we press the button. So it's going to blink when it's false, but when we release the button, we want it to turn off. So we're just going to set it to low. So no matter what state it's in, we want to make sure it goes low. Okay, let's try it out. So right now we see it turned off. When we press the button, we see it starts to blink. When we release the button, we see it stops blinking. I'll zoom in here. Right, so we know it's not just the function of the button directly going through to the LED, because it's doing additional actions as interpreted by the CPU to be able to add that capability. So already we see that there's a lot of potential value for what we want. Maybe we want it to be a delayed on, maybe we want it to be a delayed off, you know, and just have a button press to say, I want this on for 15 minutes. You could do that. Or you could attach it to other types of switches, like let's say a motion sensor, and be able to send an email based on that state. So things like that are a really useful way to be able to use it. And Python is a great way to do that. You know, so, but for right now, let's actually get out of the Python world, and let's say we wanted to just keep this simple and go low level. So before we exit, let's make sure we clean up our GPIO in order to make sure that it's available to use for other processes, like what we're about to look at. Right, so we just did GPIO cleanup. So now if we did try and rerun, for example, If we did try and run this again, so one of our outputs, it would say that it's not set up. So that's what cleanup does, is it uninitializes all the GPIO pins that we set up while we were running this. And then to exit the actual Python runtime, we hit Control D, and that will bring us back to a regular prompt. Right, so now I just cleared the screen, and we're going to move on to actually trying to just do this directly from the command line. And there's a low-level type of library that we can use to be able to do that. And it's called libgpiod, and it's very lightweight. So we do apk add libgpiod. And again, I've already pre-installed it, so it doesn't have anything to install right now. But it actually offers pretty low-level communication with the actual GPIO chip itself. So for this, we can type GPIO info, and I'm going to do or less because it's going to scroll off the screen otherwise. But we see on GPIO chip 0, we have 54 lines, and that's more than we actually have GPIO pins. But it actually incorporates some other functions for things that don't come out on the GPIO, like network and things like that. So like LAN run boot, we see there some SPI, things like that. So, but we see a lot of the GPIO headers. We see Wi-Fi clock, we see a lot of fun things like that. And then we see two other chips that are present, including CAM, HDMI, power low, and status indication, as well as shutdown. So some really good, useful things to have, but we're only going to be concerned about standard GPIO for today. So this will actually, the line number that we have is the number that we need to reference it going forward. But so just take note of it. And in this particular case, our LED is on GPIO 17, and on GPIO 14 is where we have our other button, which is actually TXD1. So that is GPIO 14. They do go in order and correlate. So it's the same annotation as what we did in Python in terms of how we refer to it. So I'm just gonna escape right there, go back to the command line. So let's just set our LED. Let's just turn it on. So the command is GPIO.set. Then we need to define what board that we're currently using, because we saw that we had, or the chip, I should say, because we saw that we had multiple chips available. And if we actually look at this, we see right here, it says GPIO chip 0. We could actually type that out fully, or we could just put a 0 as shorthand. And then we got to define what our pin is. So what pin do we want to modify? So in this case, we're setting a pin, so we want it to be an output, so we're going to choose 17. And then we're going to tell it what we want it equal to. And our options are 0 or 1 in this case. So it's off right now, so let's go ahead and turn it on. And we see it turns on. And let's say we want to turn it off. And it turns off. So with a very simple command that you can integrate into any kind of shell script, you can have pretty basic GPIO interaction to be able to provide status indication LEDs, be able to maybe take button presses. But wait a second, we didn't cover button presses yet. So what do we do with that? So as far as taking input, there's a couple of ways that we can actually read it. One of them is actually using GPIOmon. And GPIOmon is really nice because it will tell you in real time what the current status is. And again, we have to set the chip number, and then we have to tell it what pin we're listening on. In this case, it's going to be 14 because that's where our button is connected. Now, what we see here is because I didn't reconnect our pull-up resistor. So this doesn't have the internal pull-up resistor. So it's going to rely on the external pull-up resistor to be connected in order to make sense of it. So just as far as the anatomy of this, we have our event right there. We have which direction it's going, right? So when I press it, we're pulling it to ground. So it's now pulling down the voltage to 0. So it's falling right there. And when I release it, we see it goes rising because it's going back up to 1. So it tells you which direction you push the button. And we see it's watching for the edge, right here. And it says there's an offset. We don't have to worry about that. But the key thing here is it also gives us a timestamp. So if we have a long delay between it, we can actually see how long since the last time we pressed the button. Because something definitely to keep in mind is with physical buttons especially, there's no, when it actually makes the contact, it may actually bounce the connections, and the computer is fast enough to where it will potentially read all of those button presses. So if I Control C out of this and I clear the screen and then run the command again, and then I press the button, see how there's occasionally more than one entry that's created. That's because the input is pretty much bouncing. So it's seeing it go a certain direction based on the trigger for what it actually takes to say whether it's rising or falling. It's going past that point multiple times with a single press. Now, there are ways to actually go about making sure this doesn't bounce, okay? And it's called the debounce circuit. And you can use things physically, like capacitors or other things like that, or other transistors, to be able to make sure that only a clean pulse gets through to be detected. But there's also, normally the way that you would do it on a Raspberry Pi is you would add a little bit of delay in order to make sure that you're reading it only every so often. That way it kind of settles down, and hopefully you're reading it frequently enough to where they're pressing it for long enough for it to actually be detected. So that's something I would say about that. So obviously this wouldn't work for that because it's reading all the time and it's blocking any other program. So there's another command that we can use called GPIO.get. So I'll Control C out of there, we'll clear the screen. Let's do GPIO.get. Again, we're gonna do chip 0, and then we're gonna do 14 for our pin. And we see it says 1. I'm gonna press the button, press it again, and we see it says 0. So we're just directly reading it. So we can actually put that in a loop as well. So we'll do while true, in this case lowercase, do GPIO 014, and then we'll do semicolon done. And it's just going to start printing them out to the screen. Let's see, what did we do here? Unexpected do. I spelled while wrong. I don't know if you saw that. Probably better than me. Right? So right now it's going, we didn't put a sleep command. That's probably not great. Let's put in a sleep command here. So we'll do sleep 1 semicolon as well. There we go. That's more reasonable. So now as I press the button, we see it updates in real time, but because we have that delay, we're not actually reading the bounce. We're only reading it at a certain sample in time, and we're just checking whatever the present state is. So that makes it a lot easier to be able to track. So if we have a bash script or something like that that's looping, and we want to have a button to say whether we should continue processing or not, we could do that. And it would be able to check it every so often. As long as we hold it long enough for it to loop around and be able to check it, it would be able to detect it and exit successfully. So, oh, Sid Ruiz Arturo, thank you for Thank you for commenting or chatting in the screen here. And thanks for coming to the stream. I definitely appreciate it. So, but we're actually getting to the tail end in terms of what I have prepared. So any questions or anything else like that since you're on the stream? Oh, and I have giant delay, by the way, enabled. So it's not low latency at all. So it does closed captioning and all of that. So, but if anything comes up, you know, always feel free to reach out in the comments. I do my best to actually respond to every single comment that comes in. I don't get that many, so it's not a huge deal to be able to do it. But it's definitely something where I like GPIO, especially and on the Raspberry Pi, just because that was really the first device that really made it accessible. There were ways to do it before that using like parallel ports, like the DB25 parallel ports that they use for printers, and serial ports using some of the signal pins associated with it. And I know Microsoft Basic, but it was something where it wasn't nearly as intuitive and as straightforward, and especially not available in the volume that it is now on the Raspberry Pi. So it's certainly something where whatever you can think of in terms of how to integrate it into your projects, being able to electrically make it talk to other equipment is a very enjoyable thing, and especially makes it more useful if it's something where you need a different startup mode or something like that. So thanks for watching the stream today. If you like it, be sure to hit that like button and leave a comment down below. And if you haven't subscribed, please subscribe. It helps me out a lot. And if you know anybody who would like this content, you know, be sure to share it with them. I would appreciate it, and I hope they would appreciate it too. So until next time, take care.